Okay, so for today's class, we're moving on to a new chapter on algebraic fractions. So you can see here, it's just bolded there. This is going to incorporate a revision of chapter 30 from book 1 and also the higher level parts, which will be in chapter 9 of book 2. Okay, so I'm going to be covering both of those chapters within the maths I'm doing here. Okay, so we're going to start with what I'm calling adding and subtracting algebraic fractions 1. And those ones that's written here are when the denominators are numbers. And then, what did I say, Friday? So Monday then we'll do adding and subtracting algebraic fractions 2. And that's where the denominators are not numbers. They're actually little expressions. So they have x's and y's and stuff in them. Yeah, and we'll work through then multiplication and division and stuff. Actually, to be honest, adding and subtracting is harder than multiplication or division when it comes to algebraic fractions. So unusually, we're kind of almost starting with the hard part. Now, there's some tricky multiplication division questions, but I think conceptually these are the hardest. Okay, so what we're starting with here is clearly not an algebraic fraction. What would make it algebraic is that it would have a variable in it, like an x, a y, an s, an or, whatever. This one doesn't. Okay, so this is just to remind you, how do you add and subtract fractions? Okay, so when adding or subtracting fractions, you must get a common denominator. Okay, and then seems to be the bit that everybody forgets. Once you get the common denominator, undo that. You must adjust the numerator accordingly. Okay, so hopefully everybody remembers, but just in case, never assume, the denominator is the bottom line of the fraction, and the numerator is the top line of the fraction. Okay, so you can't subtract these because one is 3/5 and one is a third, and they've got completely different denominators, so it's impossible to subtract them unless you're going to start kind of drawing out some kind of figures divided up into fifths and thirds and see can you figure out how to start. I actually don't even know where to start. So what we do is we make the denominator common or the same. Okay, so when you're trying to get a common denominator for two numbers like 5 and 3, you're looking for ideally the smallest number that they both divide into evenly. So you're looking for the lowest common multiple. Now, if you don't end up with the lowest, it's not the end of the world. So the main thing is that you're looking for a number that both of these divide into. Yeah? So a number that they both divide into, I think is 15. And the sign's minus and 15. Okay? So I'm changing the denominator of the first fraction from a 5 to a 15. Yeah, so to go from there to there, I'm multiplying by 3. Agreed? That's been times by 3. So if you times the bottom line by 3, you must make the same adjustment to the top line, which means you have to take the top line and multiply it by 3. And 3 times 3 is 9. Okay? And then likewise, the denominator here is going from a 3 to a 15. So that's actually been multiplied up 5 times. So you must make the same adjustment to the numerator, which is to multiply it by 5. And 1 times 5 is 5. So now you have 9/15 minus 5/15. Much easier to do. How many 15ths do you have? You have 4/15. Okay, So that is just a reminder. You would have done that in like primary school, and hopefully you should have done it last year as well. I definitely did it just before Christmas there with my first years. Just a reminder. Now, a question like that, as in literally if for any reason that was on your paper, you do it in your calculator now, but you need to be able to do the maths to be able to do the algebraic version because they can't go to your calculator. Okay, so just make sure you understand everything I did there because I'm now going to apply it to this. Okay, so it is subtraction. You can see that here. And I do not have common denominators. I have a 3 and a 2. Okay, so you cannot subtract fractions unless they have a common denominator. So your common denominator here, I think, is going to be 6. Sorry, I'm just going to write it again because I think I need a bit more room. Minus 4x minus 1 over 2. Okay, so my common denominator is 6. I'm going to write a 6 here. Give myself a line, put in the minus, give myself a line, 6. Okay, so let's have a look. So this denominator is going from being a 3 to being a 6. So it's been adjusted by a factor of 2. So what am I going to have to do? I'm going to have to take this top line and multiply it by 2. Yeah? So we write that as 2 times 3x plus 2. I'm taking what was the top line and I'm multiplying it by 2 because that is the adjustment that was made to the denominator, and I must make the same adjustment to the numerator. Okay, I'll change colour and we look over here. So here the denominator, the bottom line, is going from a 2 to a 6, which is multiplying by 3. So I'm going to have to take this top line and I'm going to have to multiply it by 3. Same adjustment to the bottom as the top, or top as the bottom. Okay, so I write that as 3 times 4x minus 1. Okay, now at this point I think really helps. Okay, you don't have to do it, but I think it helps if you merge them. Okay, so by that I mean if they both have the same denominator, you can just write them as one big sum. So it's 2 bracket 3x plus 2. I have a minus here, and then 3 bracket 4x minus 1, and put it over 6. Since they were both over 6, you can combine them and put them over a single common 6. Okay, so it'd be like in my previous example, the merge isn't really necessary up here, but let's say I did. So if I did, let's say I did the merge step up here, I would have 9 minus 5 over a single 15, and 9 minus 5 is 4 over 15, which is exactly what I got here. Okay, so this is what I'm doing in the merge step. Okay, this is probably too simple to require a merge step, but it definitely helps with these. Okay, so I think you should do the merge step. Now, if you look at what we have a number outside attached to a bracket, which means I need to distribute it across that bracket, which we know how to do. And here I have a number outside, which we have to distribute across a bracket, which you know how to do. Okay, so 2 times 3 is 6, and then no letter and just the x. Acknowledge that this 2 is a plus 2, so we're multiplying a plus 2 by a plus 2. So the signs are the same, which means I get plus, and 2 by 2 is 4. Let's look at the 4x and say that it's positive. So we have different signs here, giving us a minus. The 3 by 4 is going to give me 12, and only the 4 has a letter, so we put that down. And then the final multiplication is the minus 3 and the minus 1. So same signs give me plus, and 3 times 1 is 3. And don't forget that that still has a denominator of 6. Okay, so now we're going right back to the start, and we have families. So I have the x family, and I have another member, and I have the constant family and another member. So it can be, if you remember the word, simplified. Okay, so for the x's, 6 minus 12 is minus 6 for the x's, and a 4 and a 3 makes plus 7 for the constants over 6. If you have a look at the question, you were asked to write as a single fraction. So it started as two fractions with a minus in between, but it has finished as a single fraction. Give me more time to do this. Answer squared and anything. Huh? I've committed now. There you go. Right, that's how you do them. Okay, so a lot of those skills towards the end you had already. Really, the only thing I was teaching you there was the common denominator part, and how you, whatever adjustment you make to the bottom line, the denominator, you must make that same adjustment to the top line. Okay, and how do you do it when it's algebraic? So when we're multiplying something into an expression, whatever we're multiplying by normally goes to the front. So we just put it at the front. Okay, likewise over here, put it at the front. Yeah? And then the merge step is very, very important. In case you haven't figured out why, it gives you that minus belongs to that 3, because that's how you write it. Okay, otherwise pretty much everybody would have got this second bracket wrong. Okay, basically here this would have been wrong. Okay, so the merge step is important so that you get the signs right. So I feel very strongly that you should do the merge step. Now it can be done without it, but I still think you should do it, at least until you get good at it. And then here, multiplying distributively across bracket, you've done already. So hopefully you remember how to do that. And then this top line, we were left with things in the same family, which means we can simplify. So we did. And we're left with a single fraction. Okay, so I have 3 questions for homework. So have fun with that.